Welcome back, everyone, and thank you for joining again. Let's take a look at another application of polynomial functions. This time, we are given the volume of a rectangular prism as the polynomial v equals 6x cubed minus 7x squared minus 23x plus 30. Now, our task is to determine possible polynomial expressions for the dimensions of the prism. So let's begin by reading the question carefully. Notice that we are not being asked to find the numerical dimensions of the prism. Instead, we're asked to find polynomial expressions that will represent the length, the width, and the height of the prism. So I want to point this out because it is something that students often find confusing. Many application problems ask you to solve for a specific numerical value, but this is different. Here the answer is expected to be an algebraic expression or algebraic expressions, not numbers. So let's think about what we already know. How do we calculate the volume of a rectangular prism? Well, the volume is given as the product of the length, the width, that we're talking about the length and the width of the base, and height, with the height. So since we are already given the volume of a polynomial, our goal then is to rewrite that polynomial as the product of factors. And in other words, we need to factor this polynomial completely and see how many factors it has, hopefully 3 that are easy to find, and assign each factor one of the dimensions of the prism. So once the polynomial is in factored form, each factor can represent one of the dimensions of the rectangular prism, and the order doesn't matter. A factor could represent the length, the width, or the height, but together their product must equal the given volume. So our first step is to factor the polynomial completely. So I'm going to rewrite it first as 6x cubed minus 7x squared minus 23x, and then plus 30. Now, this is quite straightforward. We have a polynomial of third degree. The leading coefficient is not 1. It would have been nice if it were, but it's not. It's a 6. And the constant term is 30. So from the leading coefficient, we're going to get the possible values of a, plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. Now remember that when the leading coefficient is different than 1, our factors will end up being in the form ax minus b. And that's why we need to consider the values of a in here that we need to put in here. Just so you know, just so that you remember it from the remainder and factor theorem. Now, for the values of b, we're going to have plus or minus 1, plus or minus 2. So b is a bigger number and quite an interesting number as well. So 5, and then we have the 10, and we have plus minus 15, and plus minus 30. Oh, finally. Plus or minus 30. Okay, so that will help us determine the possible values of b over a. And I'm going to list all the possible values in here. Remember how we do this? So we take a b value divided by every a. The next b value divided by every a. And just for the fun of it, I'm going to go over each and every b over a value so that we kind of refresh our memory as well. So we'll have plus minus 1, plus minus 1 over 2, plus minus 1 over 3, plus minus 1 over 6. Now we're going to work with plus minus 2, dividing every term here. So plus minus 2 divided by 1. Now plus minus 2 divided by plus minus 2 will give plus minus 1. We already have it listed, so we don't have to do it again. So plus minus 2 over plus minus 3 is plus minus 2/3. And then plus minus 2 divided by plus minus 6 is plus minus 3, so we don't have to list it, so it's not that bad, huh? So now we have plus minus 3 divided by plus minus 1, plus minus 3. Now plus minus 3 divided by plus minus 2, plus minus 3 over 2, plus minus 3 divided by plus minus 3, that would be plus minus 1, which we already have, and plus minus 3 divided by plus minus 6 will be plus minus 1 over 2, which again we already have, so we don't have to write it. Next we'll move on to plus minus 5, and then again plus minus 5 over plus minus 2, we don't have that, plus minus 5 over 2. Plus minus 5 divided by plus minus 3, that will be plus minus 5 over 3. 5 is quite a unique factor, so plus minus 5 divided by plus minus 6, it's going to be, or stay the way it is. Now we'll keep going with plus minus 10. So plus minus 10. Plus minus 10 over 2 now is going to be plus minus 5. We already have it. Plus minus 10 over 3. Plus minus 10 over 6, that would be plus minus 5 over 3, which we already have right here, so don't have to list it. And next we have 15, plus minus 15 over 2, don't have this. Doesn't simplify, so we don't need to check here. Plus minus 15 over plus minus 3 is plus minus 5. We already got that. Plus minus 15 over plus minus 6 are both divisible by 3, so that will give 5 over 2. And we have 5 over 2, so last number, 30. Plus minus 30 over 1. Plus minus 30 over 2 is going to be the plus minus 15 that we already have here. Plus minus 30 divided by plus minus 3 is going to be plus minus 10. We got that. Plus minus 30 divided by plus minus 6 is 5 that we have already. So these are the possible values of b over a. So what we do with these values now is try to check and see which one of them will give us, or will give the polynomial a value of 0. That's the remainder theorem. Now, we're going to try the value of x equals negative 2. Obviously, you want to try them in order. I kind of figured that out in advance. But v of negative 2 in our case would be equal to 6 times negative 2 to the power 3 minus 7 negative 2 squared minus 23 times negative 2 plus 30. So we have negative 48 in here, negative 28 in here, positive 26, and positive 30, and that will give 0. So that tells us that x minus negative 2, or even better, x plus 2 is a factor. So we got one of the dimensions. Now we need to figure out the rest. And for this, we're just going to divide by x minus 2. Synthetic division works just fine. So we have 6, negative 7, negative 23, positive 30. Remember where you get these numbers from, the coefficients of our polynomial. We're going to bring 6 down, times negative 2. That will be negative 12. Here we go, negative 7 plus negative 12, negative 19. Negative 19 times negative 2 is 38. Add again. So we're going to get a 15, negative 30, and as promised, the remainder will be 0. So when you look at this expression, you know that the first will be the coefficient of x squared, x, and then 15. So the factors for this volume so far are x plus positive 2, and then 6x squared minus 19x plus 15. So we're going to say that in this case, we can just simply factor the second trinomial, or the second factor in there. So, and what works in this case is 3x minus 5 and 2x minus 3. And this is going to be the completely factored form of for the volume of this prism. And we're going to say, in addition, that each factor will represent one of the dimensions. And we're going to say maybe this is the length, this is the width, this is the height. And our final statement would be that the dimensions of the prism are or rectangular base box, so it doesn't really matter. So x plus 2 by 3x minus 5 by 2x minus 3. Now, there are no real restrictions that we can place in here, but we do need to state that each dimension has to be a positive number. So we're going to say x plus 2 is positive, 3x minus 5 has to be positive, and 2x minus 3 has to be positive. Now, further to this, we're going to place the domain of each factor, x bigger than negative 2, x bigger than 5 over 3, and x bigger than 3 over 2. Because each dimension has to be positive. And we can put all these on the numbered line. So we have negative 2 here. Yeah, there is 0. And we have somewhere in here, we have 3 over 2. And 5 over 3 will be a little bit further to the right of. Let me just put it this way, so because they're very close to each other actually. So 3 over 2 is 1.5, and this one is going to be 1.6, okay? So I'm going to make this 1.5 in here. So that's 1.5 and that's 1.6. So that means that we need the numbers to be, you know, greater than negative 2 and greater than 5 over 3 and greater than 3 over 2. And that can happen only when they're all greater than 5 over 3. So we're going to say that x has to be greater than 5 over 3. So in the next video, we're going to look at the last example, example number 3. See you soon.